Hi, everybody. My name is Stefania Serafin. I'm Italian, but I work in Copenaghen, Denmark, at the Technical University of Denmark. For the last 10 years, we have been having a collaboration with the Danish Music Museum. The Danish Music Museum is a museum in Copenhagen. Like many other museums, like the one we'll see tomorrow, they have a lot of nice artifacts. But they are all behind the glass. I'm going to show you different projects that we've been doing with the museum over the past 10 years. The first one I will show you quickly to show the different possibilities of how technologies can be used or how we use them. It's, of course, not the only way. And also, then I will focus on two projects where we dedicated more time because we had a human-centered design approach in collaboration with the personnel of the museum. So I'm going to show you, first of all, a quick tour of the museum so you see how it looks like. So it has a lot of historical instruments, but also, as you can see, some modern interfaces, which don't necessarily reproduce existing instruments, like the one that you see here. And this is one of the trademark instruments of the museum that I will talk to you about later. It's called the amoeba violin, or the harp violin. So how do we do so the idea of the museum, like everybody else, is how can we make these instruments alive, but without having the audience touch them, obviously not to ruin them. So one possible way that we explored was by using augmented reality. As you know, augmented reality can be achieved, for example, with a mobile phone, and you use the camera of the phone and you create some experiences interacting between the physical artifacts and the virtual one. So one example is making this Buritzel theater organ alive. This is a theater organ which was used a lot in theaters to play music with mute cinema, for example. One of these organs is available at the museum in Copenhagen, but again, we cannot touch it. So I'm going to show you a quick video of how we made it alive in augmented reality.
Ready? Yes. Oh. He's very good at sitting. Yeah.
So this is one of the instruments that were made alive by pointing the camera to the instrument, and then a virtual player comes up and plays, so you can hear in a more playful and interactive way how the instrument sounds like. A different option, like also Michele described, is by creating tangible interfaces or tangible replica. So he has already spoiled a little bit my demo or my question, but would you know which instrument this is? So if you were listening to Michele's presentation, you will be able to answer this question. Let's see. Do you know which? This is the tromba marina. So what is the tromba marina, for those that don't know it? It is a bowstring instrument, and the reason why it doesn't sound like a traditional bowstring instrument, but it sounds more like a trumpet, it is because it has a bridge which is not attached at both sides, like traditional bow-string instruments, but it is rattling. And this rattling mechanism creates this tromba, which obviously means trumpet sound. So regarding tangible interfaces, we recreated it faithfully, or as faithfully as we can. In this project, we didn't have any instrument maker involved. It was more like other kind of makers, let's say. And I'm going to show you the video. So this is an example of tangible interfaces to recreate the instrument, to preserve again the one from the museum. The same can be achieved in complete virtual worlds. So in this case, the same virtual marina, not virtual marina, the virtual tromba marina was reproduced in virtual reality. We were talking this morning about haptics. So the ability to recreate the sense of touch. In this case, we used this device that you see. It's called Phantom device. It is a 6 degrees of freedom haptic interface. The advantage is that it gives you the same force feedback that you feel when you have a bow on a string. The disadvantage is that, as you can see in the video, it cannot be moved as much in space as, let's say, a real bow. So here the experience is completely virtual, apart from the interface. Now I'm going to show you something a little bit different. So the personnel at the museum was also interested in what we can call alternative installations, which means that they are musical instruments which they don't necessarily represent any real, so they don't have any historical relevance, but they allow the visitors to the museum to come and play with music. So this is an example of an installation where you are a conductor. You are a conductor that plays an instrument, controlling the frequency of the instruments and how you interact with it. So it's more like a combination between artistic representation and the ability to play virtual instruments. This is actually not from our group. This is something else that is present at the museum. It is basically just, it's more the look of the instrument, which is nice, rather than the features, because it's like a big mushroom. You press the different buttons, and each button is connected to a specific sound recording, basically. And you can, I mean, there is a digital library. You can obviously connect any kind of button to any kind of sound. And then it's nice for children who visit the museum. It's very, very sturdy, as you can see. So children don't break it. On similar vein, you have seen probably a lot of these reactable-like musical instruments, where you have cubes that you move around on a table, and then these cubes, they create music. This one is quite special. This one, the instruments are actually gun clicks, and it's an installation by the composer Nolan Dam. And the idea was to simulate the frequency of gun shooting in the United States. So it's quite special that the instrument actually allowed to have it in so the museum allowed to have it. And actually that was allowed by the personnel of the museum that we collaborated with, but obviously it created a little bit of controversy. Also, is it actually a musical instrument that should be in a music museum? That's something that can be discussed. Luckily, I don't need to talk much about physical models because Riccardo made a great introduction. So this is one of the techniques that we use, and we are going to use more on the following project that I'm going to show to you. So as Riccardo very well explained, we use physical model to create a software simulation of the musical instrument involved, like the tromba marina that you saw and others that I'm going to show you later. And yeah, exactly. With the physical models, we can resurrect the real instruments, and we can recreate how they sound, either with having measurements, like also Michele talked about, measurement from the guitar, and the documentation that you can use to create these simulations, or when you are allowed to, by having recordings that are used again for the simulation. So, so an important aspect of physical models is what is called the exciter-resonator approach. So any musical instrument doesn't make any sound until we interact with it. So in the case of the tromba marina, it's like a kind of a stick. Doesn't make any sound until we excite it. And we have been interested for some years or so as part of my PhD on sound of friction. So what is friction? Friction is what happens, for example, in the case of a bow with a violin, but also if you take a wine glass, not this glass, but if you have a nice wine glass and you rub the rim, that is also the sound of friction. Or also when you open a door, that is also friction. So this exciter-resonator approach is very nice because you can have a model, a physical model of the interaction and a physical model of the object, and then you can mix and match them together. So in the case of the tromba marina, actually with Michele, we published a paper on the physical model. And as we said, the string, how to simulate a string physically has been very well known for centuries. But what is maybe more special is this vibrating mass spring system that represents this rattling bridge. And this is what creates the particular sound of the tromba marina. And then the body has been simulated a lot, just as a plate. This is sufficient to get a good sense of a small reverberator. So this is just to give you an idea. You take the different elements, you simulate them mathematically, and then you can put them together, and you need to make it as efficient so you can actually play it in real time. It's stuck. So yeah, we showed that once you have the model, then you have a real-time implementation, and then you need to find how to play it. And as I showed you before, with the tromba marina, we used this device, which has the possibility to move in a three-dimensional axis. And then what you need to decide is, how do I map, how do I take the input from the device and assign it to the parameters of the model. So for example, the velocity of this pen can be mapped to the velocity of moving the bow, and so on. And that gives you a complete virtual instrument. But these are some little artifacts. A couple of years ago, we had a bigger project with the Danish Music Museum. This project was supported by a Danish foundation, which is called Augustinus Foundation, which is very interested in cultural heritage. And the idea of the project was exactly music out of the box. So I'm going to show you now some slides that are from a design sprint, which we did together with the personnel of the Danish Music Museum. So for those of you who don't know, a design sprint is a methodology where in few days you design and test a prototype. The idea of design sprint is to create very quickly a prototype of a product in such a way to start to understand what can be the issues and what can be the limitation before designing the actual final product and using a lot of time. So in this sprint, 2 days, so the goal of the sprint was exactly to create digital and also analog. So it was very important that the reconstruction was not just a virtual reality simulation, but it has also a tangible physical artifact. And regarding this museum where all the instruments are inside the glass. So the question of this sprint was, how can we create a multisensory experience for the museum guests? And then, I mean, this sprint was designed also among the participants. It was a very heterogeneous group, also including musicologists and personnel of the museum who didn't know what a prototype is. So there was an explanation of what a prototype is. So a simplified artifact which addresses a specific problem without going through all the iterations to make a final product. So quick and fast prototyping. And as I said, it was based on this, how might we? It's like a principle from Norman, which is a Danish designer. You describe how, and then you discuss, and it's very important to work as a team with interdisciplinary knowledge, like the people that were gathered in this sprint. So this is Monday, is like Monday. So on Monday, it was all about discussion and idea generation. And Tuesday was prototyping and testing. So as you could see, it was a quite fast and dynamic process. So the test, of course, you need to find an hypothesis. And what do you want to gather from the test? And so this is all questions about what should we do, how should we design the prototype, what should we test, and who should we test it with. And then we design different what is called personas, which are like some different kind of individuals that might visit the museum, and which kind of experience do they want. It's not the same if a child comes to the museum and wants to interact as much as possible, or maybe a person which is more cultivated that is happy just to read, doesn't need to touch everything, so on. How can we create an experience that makes everybody happy? Probably not. And then this was like, what did we learn? And these are some results from the test, the people we tested. So during this sprint, we chose this instrument. I'm not really sure why. It is like a stick that was using wood to make sounds while soldiers march. But then when we actually went into the real project, we chose 2 completely different instruments, luckily so. So the first instrument is what is called the glass harmonica. The glass harmonica is an instrument which was invented by Benjamin Franklin in 1761. So Benjamin Franklin attended a concert where there were lots of wine glasses that were making music. As you know, if you have a wine glasses and you rub the rim and the glass is filled with different level of water, sometimes you see in the street, you can hear very nice melodies. So he said, why can't we make it with cylinders? So cylinders of different radios, like you see in the picture in the bottom. This is actually the glass harmonica that we have at the Danish Music Museum. Behind the glass, you don't see the glass, but there is a glass also here. And on top, there is the reconstruction, the 3D reconstruction made by the researchers involved in the project. As you can see, it's quite realistic. So this experience is a complete virtual reality experience. What happens is that you enter a virtual reality experience and you are taught by Benjamin Franklin himself how to play the instrument. And you're also given a little bit of history. So there is also a narrative aspect. Instead of just taking the instrument, play and go, there is some entering the experience and then exiting. I'm going to show you a video. It is Benjamin Franklin speaks Danish because that's what the museum asked us. But you can see, you can get an idea anyway. I hope.
Jamen, goddag og velkommen til mit kontor. Mit navn er Benjamin Franklin, og det er mig, der har lavet instrumentet foran dig. Glasharmonikaen. Hvis du starter med at tage dine hænder op foran dig og vrikker med fingrene, så skulle de meget gerne dukke frem. Godt så. Du kan prøve at spille på instrumentet ved at lægge dine pegefinger op på toppen af glasskålene.
So the person is with the fingers playing the virtual reality, and Benjamin Franklin says, oh, well done. Now you can play the instrument. In this case, the prototype of the environment. Yeah, here it says when you have learned, when you have understood how it works, then press the button and then you can play other experiences. And the interaction is simply the virtual reality display has a camera, so you could have touchless interaction, and the sound is generated by one of those physical models that we talked about before. One of the issues in this case is that you see the instrument, you move the finger, but you don't feel, you're really missing the haptic feedback. And that is actually a problem because it would have been nice to have maybe a tangible interfaces positioned at the same place as the virtual instrument, so you actually feel also while you play. So yeah, this is, it's nice because there was a scenographer involved, so made, instead of just one of those lab prototypes, they made something that works well in the museum, and you can see what the person is looking at, which is one of the problems in virtual reality, that you have no idea what the person is doing. And here is like the director of the National Museum, and I'm going to show you just from the outside what a person does. So it is, so as you can see, it's very easy to learn to play. You just move, but this haptic feedback, so there is, of course, a trade-off between having even more hardware but having also more realistic experience. The second installation from the same project is regarding the violin arpa, which was invented in 1873. Nobody really knows precisely why such a shape was needed, because it's so unergonomic, and we don't have recordings, so we don't actually know if it sounds better or not. So again, physical models come to the rescue, because you can simulate the shape of the body, and then the goal of the installation is actually, so you have here a physical bow, and you bow the screen, basically, or there is like, so you're bowing a violin. It's a bit not very comfortable. But then you can change the shape of the violin and make it as the arpa, and then listen, oh, how does the violin change when it is a regular violin towards when it is an arpa? We don't have recordings to validate our simulation, so we don't know if it is right. So we can just trust the simulation, I would say. And in this case, it is, so the person listens what they are playing, And it's a little bit hard because, so this is a screen. So you are playing, instead of wearing the violin, you are playing it on the screen. So it is not very comfortable. But they really liked this idea of stretching the body and reshaping it. So you could think about having instruments of different body shapes, and then you can, thanks to the digital simulation, you can actually hear how they sound like. And this brings me to some considerations that came up after working for 10 years now with the Music Museum. So the most important thing is those installations, they really need to be very simple to work in the museum, because the personnel really is not, doesn't have the time or even the competencies to maintain them. So in this case, when we had the bow, sometimes the sensor was not really behaving as expected, and then every time the researcher had to go and fix. So the simplest they are, of course, the less maintenance they require. Again, yeah, that's so connected. These digital simulations, they always require both physical but also software maintenance. So if you have an app, the software needs to be constantly updated, and also the hardware. So that also requires some considerations, not only from when the artifacts is put in the museum, but also how to maintain it afterwards. And this is connected to the fact that it would be nice to have as least hardware as possible to prevent having these maintenance issues. Also, we were discussing a lot about, do we want to entertain the visitor? Do we want them to learn something? We want to both, ideally, but who are we teaching to? Everybody can potentially visit a museum, and different individuals have different preferences, different needs, different ways to visit the museum. How can we do in such a way that the artifact satisfies as many wishes as possible? Because we cannot create a reproduction for each preference. Another important issue is, of course, accessibility. How can we ensure that everybody, or as many people as possible, can actually enjoy and interact with these artifacts? So having said that, I had prepared actually some questions, since this was before lunch. I had prepared some questions. I don't know, can you read in the screen? I wanted to have a little bit, I don't know if it is okay, maybe you want to do differently, but I wanted you to have a little bit of discussion with the person sitting next to you about these questions, and then we can discuss all together and then go for lunch. And this maybe doesn't require to be necessarily only regarding my presentation. It can be also about the presentation that you saw this morning. If there is something that made you more aware of something that you think is really not working, or what inspired you, and so on.
So I gently invite you, if you have any questions about the morning we had, you are kindly invited to present them now as you like, or even to me, if you prefer to come here, as you like.
Credo che stanno discutendo. Yeah. Oh.
Yep. Oh.
Yeah.
Yeah.
Yeah, very interesting presentation and a lot of interesting examples. My question would be, Is it working? Yeah?
Yes, now
Okay.
yes. Now yes.
Yeah, my question would be, how can other museums or institutions profit from all these developments? And it's not only your projects, but also the other projects that were presented this morning, because we were talking about open science and exchange and so on. And I mean, my perspective is also sort of egoistic, because I think, well, great projects, how can I also implement it into our exhibition? But maybe this is also not wanted. So the question is, how can it be exchanged? And also, were your projects, for example, were these singular projects with one goal, or was it a more wider approach, more general approach?
This is an excellent question, and it's connected to the issue of maintenance, but also not just maintenance, but also like how to widen the the development of these instruments. So in this case, they were mostly specific to the place, because the glass harmonica is specifically the one, for example, of the museum, and also the violin. But for example, the glass harmonica is very, very easy to bring to other places, because it is simply a virtual reality installation so a virtual reality software that I would be very happy to share, and that is easy to share, and especially if other places also have the same, or a glass harmonica that can be interesting. Other cases, I mean, I think it really depends. It's in general what we were discussing about open science. Software is very easy to distribute, if, of course, if the people agree to do it. The hardware side is a little bit more tricky, because it requires, both of the instructions how to build it, but also somebody who has those skills, let's say. But software-wise, I think it would be really valuable and excellent to try these different solutions in different places, because it's also a matter of museum personnel. Maybe some museums are more open to this kind of innovative projects than others. As you could see, the Danish Music Museum already had like this kind of musical table, or this, they've been trying to, mostly because that they had an issue with younger audience, especially, really not being interested to visit and just see some beautiful objects, but we are behind the glass. So that was not, so their main goal was to attract a younger audience to the museum.
Thank you very much. Other questions?
Leggo una domanda da Sandra Suatoni. Quale forma di fruizione tra quelle illustrate è risultata più gradita al pubblico?
So she's asking which one was the most appreciated by the public. So I think it's the virtual glass harmonica. The one also they liked also the augmented reality making alive, because that one was not only actually for that theater organ. The researchers, they made alive, I think it was 20 of the instruments in the museum, which is very nice, but it also created challenges, because sometimes the tracking was working nice, sometimes it wasn't. So again, the visitors became frustrated. So this user testing is extremely, extremely important. Maybe something was working in the lab, so they were having picture in the lab of the instruments to prototype, but then once you take it to the museum, the glass creates reflection. The lighting is different, so sometimes it works, sometimes not. While the glass harmonica was working pretty much all the time. So I would say that's the one they preferred.
And can I use the time, because I have the mic, to ask Michele and his team a question about the naturality of sound, because you said that this model provides natural sound. How did you test? How are you so sure that this modeling is actually giving us the impression of a real instrument. And it's a provocation question, but because I like to know what kind of perception studies have been done, or if it is just an approximation, or if you are confident that this is really natural, because I guess it interests all the projects that have been presented this morning, how technology can really give us something that reality as we have known it so far is not able to.
I think that it's a problem of method. So if you are trying to reproduce the sound of anything, then physical modeling, at least before the advent of artificial intelligence, is the technique that really focuses on the mechanism of sound production, as opposed to all other techniques in computer music that focus on how sound is perceived. So if you take classic techniques like frequency modulation or wavetable or all these other techniques, they focus on how sound is perceived, not how sound is produced. So physical modeling came into existence and completely changed the paradigm in that sense. And that's why you can claim that is the most natural sounding of all synthesis techniques, just because it's the methodology that focuses on how sound is produced. That's an engineering perspective. All that comes in through psychology or the idea of approaching an instrument as an holistic system, that's a completely different thing. So restricting the attention to the mechanisms of sound synthesis, then physical modeling is the technique that will give you that that will encode that natural gestural control that is impossible to do with any other techniques.
If I can add something, I feel like we also need to define what natural means, in the sense that if we try to replicate the sound of an ancient instrument, do we want to hear the sound, like the original sound, how it sounded 300 years ago, or the sound it makes now, which is different because there is aging of wood, and there are all sort of things that may happen. Also modifications that the instrument might undergo, through times. So I don't know if there is a real sound, if we can define a real sound that we want to replicate.
Can I also add something? You talk about, because you mentioned perceptual evaluations, but I have to say that the community that works on physical models, they are not very keen on doing the perceptual evaluation, more in terms of time. So I can see that a lot. Well, in the past, actually, there were the acousticians that were just looking at the waveform. Yeah. So they were not even listening to what they were producing. Then we went to the listening offline. Now we are in the time where we can actually listen while playing. So in a real-time action perception loop. But the evaluation is something that requires to invite. I mean, it's super. I'm not saying it's not important, but I think the computer scientists and engineers, they're a little bit lazy in the evaluation.
That's why we need to talk.
But
right?
yeah, exactly. But that would be totally the way to do it. Yeah. To do listening tests involving humans is the only way to do it properly.
And also my reaction to natural was really like a semantic unit of sense. Natural to whom?
Exactly.
Natural why? Realistic, that resembles the quality of the original instrument, whatever condition it is, or something that I can play on a loudspeaker, and therefore I'm using a setup that is not the way I am engaging with the original hardware, but it's a new way. So I should have headphones to have something, my human-centered thing. I mean, we have a lot to develop and to And I am confident that sound modeling is really the way to treat sound synthesis. But my point is that maybe we have much more into a musical instrument that is not only the sound production, and it has to do with our way of engaging with it.
Yeah, exactly.
And it's so exciting because we have different ways because we are different.
Exactly. Yeah.
Grazie. Parlerò in italiano.
Va bene, sì, dopo tradurrò.
Per lei non è un problema, ma per molti in questa sala non lo sarà neppure. La sua relazione è affascinante. Vorrei venire a Copenaghen per visitare il museo.
Benvenuto.
Io ho lavorato per l'allestimento del Museo della Musica di Bologna, che non può disporre di strumentazioni acustiche, informatiche, digitali, eccetera, di gran lunga paragonabili con quelle che avete splendidamente allestito a Copenaghen. Ho una curiosità. Quello che lei ci ha mostrato è principalmente un museo del suono, nella sua sterminata, straordinaria, affascinante ricchezza. C'è una sezione del museo che si occupa di musica come arte che elabora il suono per produrre delle opere d'arte che si nutrono del suono ma non consistono unicamente nel suono. Posso anche farle una domanda più specifica. Meravigliosa la glassarmonica, ma poi si può ascoltare qualcosina del Köchel 617 o dell'introduzione alla scena della pazzia della Lucia di Lammermoor? Sarebbe il passo necessario per far sì che dall'esperienza diretta della produzione e della percezione del suono si passi anche alla sua utilizzazione. Io sono felicissimo di avere finalmente sentito il suono abbastanza disdicevole della tromba marina. Nel Museo della Musica abbiamo, mi pare, 5 trombe marine. Sono troppo pigro per andare a cercarmi i dischi dei concerti di Vivaldi in tromba marina o quei pezzi di Lully o di Alessandro Scarlatti che vengono sempre citati quando si parla della tromba marina. Questa mattina ne ho avuto un assaggio, ma in un museo come questo passo ulteriore che magari attira soltanto alcuni visitatori e non tutti sarebbe un incremento notevole. Le chiedo, insomma, se questa componente ulteriore è contemplata.
Sì, for the foreigner audience, to summarize the question is, can we also listen to actual pieces of music and not only to these like artifacts where you hear the sound of the instrument, but you're not hearing it in the context of a real musical production? And my answer is to a certain extent, in the sense that many of the instruments, they have a QR code on the glass where you can scan it and then listen to some compositions that were made with those instruments. So they are trying to give the possibility to listen to those, although it's a limited database, I would say.
Hello, thanks for your presentation. My question is, how did you start your project of use of digital technologies in the museum? When you had to decide what kind of technologies, which level of interaction for the users, what kind of experience, did you start from, for instance, a survey on the public of the museum, just investigating their needs or desires, or asking to the curators, for instance, about strategies for sound communication museum? This question is because sound communication museum is really something difficult to find because our museums are usually silent, even museums of musical instruments. And so I am very interested in this because also in our project we have this challenge to test and experiment new approaches in sound communication.
Yeah, it's an excellent question. And the way we started is from a need expressed by the curators of the museums. So they observed that there was this lack of interactions from the audience and this need to make the experience of the museum more alive and more interesting. So the way we decided which technologies to use, it was really, so we presented them with a different palette possibilities that they could have. And then I'm not really sure why we chose specific technologies for specific case studies. So in the case of, so sometimes it was coming from also like for example, those more like alternative installations. It was more the artist that had a wish to do something different. So that was, and then the museum accepted to have it. Of course, it's not a permanent installation. It was there just for a month or so. In other cases, also maybe the curator had read that a technology like virtual reality was becoming more democratized. So they were asking, can we do something with virtual reality? In the other case of the music outside the box, they had a specific requirement to have also physical artifacts. And in this case, we had the violin bow attached to the wall. So people could actually physically interact with something. So it was really always a conversation that we are having. And it's very nice because they're very open to ideas and they are a very dynamic and fresh museum. So it's